We are going to finish our chapter on quadratic functions by looking at zeros of a function. So let's remind ourselves what a y-intercept is. A y-intercept is going to have an x value of 0. So if we want to find the y-intercept, we can let x be 0 in our function and then solve for y. So let's do a couple examples. We'll start with finding the y-intercept of g of x equals 2x squared minus 3x plus 5. So remember, the y-intercept is when x is equal to 0. So we'll plug in 0 for x, and then we'll evaluate. Okay, so when we evaluate, we end up getting 5, which means our y-intercept, which is a point on the graph, is going to be 0, 5. So also recall that a y-intercept is a point on the graph where your graph is intersecting the y-axis. So it's intersecting the y-axis at 0, 5. Let's do another example. Let's do h of x equals x minus 1 squared plus 2. So to find the y-intercept, we'll let x be 0, and then we'll evaluate, and we end up with 3. So our y-intercept for this graph is going to be 0, 3. So the x-intercepts of a graph always have y values of 0. So x-intercept is when y equals 0. For a quadratic function, you can actually have more than one 0, which means that you can cross the x-axis more than once. In order to solve the x-intercepts, what you have to do is you have to let y be 0 and then solve for x. A 0, or a root of a function, is the value of x at which the graph crosses the x-axis. It is the x-coordinate of an x-intercept of the graph. So if we want to find the zeros of this function, r of x equals x squared minus 4x minus 5, we first have to let y be 0. And then we have to solve for x. So since this is quadratic, we can do several methods. It looks like this one will factor pretty easily. Factors into x minus 5 and x plus 1, which means that our zeros would be, our factors would be x minus 5 equals 0 or x plus 1 equals 0, which means x equals 5 or x equals negative 1. So that tells us that that's the x-coordinate on where the graph is hitting the x-axis. Let's do another example. We have negative x squared plus 4x minus 4. So I'm going to set it equal to 0 because I'm going to let y be 0 and solve for x. I'm going to go ahead and factor out a negative. So that way I can factor x squared minus 4x plus 4 a little bit easier. That actually factors to x minus 2 times x minus 2, which means that my zeros are either x minus 2 equals 0 or x minus 2 equals 0. And those both equal 2. So x equals 2 or x equals 2. So this is a special, we call this a double root because the two factors produce the same root. And in that case, that means the parabola is only hitting the x-axis once. So we would say that the parabola's vertex is located at that x-intercept. If we wanted to find the 0 of this function, we would set it equal to, set y equal to 0, and then we would solve. So we could add 6 to both sides. We would square root both sides, giving us plus or minus the square root of 6 on the right side, and then add 1 to both sides, and then we get our roots. There are two roots here. There's 1 plus the square root of 6 and 1 minus the square root of 6. So remember, root and 0 means the same thing. If we want to go ahead and approximate that out, we would end up with approximately 3.45 and approximately negative 1.45. If we want to find the zeros of this function, we start with letting y be 0, and then we're going to solve for x. This one we would probably want to use the quadratic formula for because it doesn't factor very easily. And when we do, we end up with 1 plus or minus the square root of negative 15 over 2. So remember, if your discriminant is negative, which is in this case, that means that you don't have any real solutions. And it means you have no real solutions. So if there are no real solutions, that means there are no real zeros. And remember, zeros are where the parabola is crossing or intercepting the x-axis. If there are no real zeros, that means there are no x-intercepts. So there's no x-intercepts or no real zeros when the discriminant is negative. All right, let's look at this example. We will find the zeros for, actually, we're going to start with finding the y-intercept. So let's go back to that y-intercept. We let x be 0 and solve for y. And that gives us the y-intercept of 0, negative 3. And then once we have the y-intercept, we know where the parabola is going to hit the y-axis. So we have 3x squared plus 8x minus 3 equals 0. So we're solving for x. We can factor this. It becomes 3x minus 1 and x plus 3. And then we can set those two factors equal to 0 and then solve for our roots. And when we solve for our roots and zeros, we get 1/3 and negative 3. So those would be our roots or our x-intercepts or our zeros. So for this one, our vertex is supposed to be h comma k. So we can recall from our previous lesson that there is a formula to find h. H is the same as negative b over 2a. So we identify our a, b, and c. A is 3, b is 8, and c is negative 3. And then we'll use our h formula to find our h value of the vertex. So we end up with negative 8 over 2 times 3, which is negative 4/3, or negative 1 1/3. Now we know what our h value is, we can find our k value. To find our k value, we go ahead and plug in h into our function. So we're going to plug in negative 4/3. So we'll plug in negative 4/3 for x and evaluate that, and we end up with negative 25 over 3, or negative 8 1/3. So now we know what our h is and our k, so now we know what our vertex is. So now we know what our vertex of the parabola is. We also know the x-intercepts, or the zeros or the roots, which means where it's going to hit on the x-axis, and we also know our y-intercept. We also know that it's going to open up because it's a positive a value. So using all this information, we can sketch the graph.